Hello everyone, we are from System Research, and this is a presentation on our work, Disentangled Control Learning for Quadrilateral Text Detection. As we know, precise detection of quadrilateral text is of great significance for subsequent recognition, where the main challenge comes from four distorted sides. Exciting methods concentrate on learning for word size to construct the contour, as shown in the left image. However, we can see that word sides are dummy intersections entangled by their neighbor sides. The regression of each independent side is influenced by two word sides, which would inevitably disrupt other sides. The learning efficiency and detection performance are surprised. In this paper, we proposed Disentangled Control Learning Network, DLCNet, to focus on clear regression of each individual side disentangled from the whole quadrilateral contour. The sides are disentangled from whole contour with independent line parameters in polar coordinates, which is easily learned with higher efficiency and performance. This is the overview of the DLCNet framework, which employs typical encoder-decoder architecture connected by channel reducer module and feature aggregation module. The output feature maps contain 9 channels. Generally, the line equation of one side could be formulated as ax plus by plus c equals 0, where a, b, c are 3 parameters. However, these parameters are actually redundant when c is not equal to 0. In other words, predicting implicit parameters abc is ill-posed, since multiple solutions exist. Their physical meanings in image are also ambiguous, which is not conducive to network learning. As a result, we convert about line equation to polar coordinates. As shown in this figure, rho is the nearest distance between origin and the line equation. Theta is the rotation angle from x-axis positive direction to above nearest direction. Therefore, the conversion from Cartesian coordinates to polar coordinates simultaneously reduces the number of parameters and the correlation between them, and brings physical meanings in image, which is beneficial for network learning. The overall loss function contains the losses of text-non-text classification, line equation parameters rho regression, and theta regression. LCLS is the commonly employed binary cross-entropy loss with online hard example mining strategy to promote the classification ability. Inspired by the LU representation, we propose real LU loss for rho regression compared with the L2, L1, and smooth L1 loss. Real LU loss could better normalize the various distance, which contributes to the multi-scale detection. The theta ranges in 0 and 2 pi. However, the 0 and 2 pi are actually the same representation due to the cycle characteristic in polar space. When the angle difference increases from pi, the loss should decrease accordingly. Therefore, we designed the sine angle loss to elevate the confusion in above transition areas. Here we evaluate the DCLNet on 3 challenging public benchmarks: ICDR 2017 MLT, ICDR 2015, and MSI TZ500. These are some example detection results of 3 benchmarks. We can see that DCLNet could accurately localize the text with any quadrilateral shapes.